Welcome everyone, and welcome to the AluVET vocational training and education for the aluminium sector. This training is co-funded by the Erasmus program of the European Union. My name is Jan Lukaszewski. I am the technical manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy, sufficient to enable students in subsequent modules to understand aluminium, its alloys, how it is heat treated, and how it is rolled, extruded, and/or welded. In this module, Elements and Atoms, we shall be learning the basic theory of atoms and metals. This project is funded with the support of the European Union. This publication reflects only the views of myself and of the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. We shall learn about the elements, that is, the building blocks of nature, about atoms and their construction and their nature. We shall then look into the subparticles of atoms, protons and electrons, and understand the construction of atoms. Then we shall apply this to metals and understand what a metal is and about what gives metals their unique properties. Having completed this module, you will understand why metals are both strong and ductile. You will understand about the metallic bond, that is the force that holds metal atoms together, and why the metallic bond gives metals their unique properties. And we shall understand why metals expand thermally and conduct electricity. So let's start looking at elements and atoms. An atom is the smallest unit of matter, and each element is a unique atom. So atoms are the smallest units of matters, and each atom is an element, and the element is a unique atom. Atoms are elements, and elements are the building blocks of nature. Elements cannot be broken down by a chemical reaction into anything smaller, so they are the building blocks of nature. Now, compounds or substances are the form of atoms that we touch in every day. The chair that you sit on, the desk that you are touching, is made up of thousands of compounds and substances, and those compounds and substances consist or comprise of millions and millions of atoms bonded together. So different atoms can bond together to form complex substances. Most metals do not occur in their natural state. Only a few metals like gold exist as pure metals. All other metals are found as compounds, either as oxides, sulfides, or halides. Aluminium is found as aluminium oxide in bauxite in nature. So pure metals, apart from a few like gold, do not exist in a pure metallic state in nature. Now let's understand what an element is in an atom. Well, an element is defined by its atomic number, which is the number of protons. Elements are unique atoms, and in the core, the nucleus of each atom, protons exist. Protons are positively charged particles that are found clustered together in the nucleus in the form of a ball. I'd like you to understand that protons are positively charged particles. Each element has a different number of positively charged protons. So each element has a different number of protons, positively charged particles in its nucleus. The number of protons in an atom never changes. So the number of protons in an atom, the number of protons within a specific element never changes. It is a constant. So each unique element is defined by its atomic number. So each element is assigned an atomic number. And that atomic number is the number of protons within its nucleus. So please understand that each element is assigned an atomic number, which is the number of protons in its nucleus. Now, the core of an atom, the ball of protons, the nucleus, is normally surrounded by an equal number of orbiting negatively charged electrons. Electrons are much smaller particles than protons and carry a negative charge. Remember, protons are in the nucleus and they carry a positive charge. Electrons are small particles which orbit around the nucleus and they carry a negative charge. The electrons orbit around the nucleus at extremely high speed in all three dimensions. The picture you see is two-dimensional, but in reality, the nucleus is a ball and the electrons orbit all the way around the nucleus in three dimensions. So they orbit like a round shell around the nucleus all around. So they cover the whole of the surface of the atom, just like the Earth and the planets orbit around the sun. When we look at a picture of our solar system, it's two-dimensional, but in reality, the elements orbit in three dimensions. So do the electrons around the protons. Now, inside the nucleus, where the protons are located, are also found neutrons. And for the purposes of this lecture, all I'd like you to understand is that neutrons have no electrical charge, they're negative, and effectively in the nucleus, they just act as spacers to separate the protons, to help the protons come together in a round ball. In terms of metallurgy, in terms of this module, all I'd like you to understand is that there are neutral particles in the nucleus called neutrons, and as far as we're concerned, we can completely ignore them after this. Thank you. Now, remember, an element is defined by its atomic number, which is the number of protons. and that the number of protons never changes within an element or an atom. Now, in the normal state of an individual atom, the number of positively charged protons in the nucleus match the number of negative electrons that are orbiting around. So in its normal state, an atom has no electrical charge. The number of electrons balances the number of protons, so the negative charge of the electrons balances the positive charge of protons. So in its normal state, an atom has no electrical charge.